First problem of the homework, we got to 40 Newton forces applied as shown in the coordinates B and D of the rectangular plate. Determine the moment of the couple formed by the two forces by resolving each force into horizontal and vertical components and adding the moment of the two resulting couples. Use the resultant obtained to determine the perpendicular distance between lines VE and DF. So, for the first part, we know we're working with a couple. Why? Because we have two forces parallel to each other, different sense, and same magnitude. So we're going to calculate what's going to be the moment that create. I don't know if it's going to be a positive or negative moment. I'm just placing it the moment created by these two forces. And for the part B, we're going to use this same moment to calculate the distance that's perpendicular to these two lines. Let's go through it. First, we gotta resolve. That means decompose my forces into components. One component that goes in Y and one component that goes in X. Since my forces are equal and have the same inclination, the magnitudes are going to be the same, force Y and force X. What I create here is a set of two couples. One couple of vertical forces and another couple of horizontal forces. So if we know that the moment created by a couple is going to be the perpendicular distance times the force, but we don't have the perpendicular distance, we can split it into forces that we know the distance between each other. And that split is going to look like this. Moment couple 1 plus moment couple 2, where moment couple 1 is going to be distance x, force y. Moment couple 2 is going to be distance y, force x. Now, you don't necessarily have to name couple 1 for the dx and couple 2 for dyfx. You can name it as you wish. For example, couple 1 could be dyfx and couple 2 dxfy. However, I like to use this notation. So where do we get the distances? Directly from the plates. This one right here is going to be dy, 300 millimeters. However, we can write it down as 0.3 meters. This one right here is going to be dx. However, we can write it down as 0.5 meters. So the last thing to get is going to be the magnitude of force in y and force in x. Force y, force x. Since we're working with an inclination angle that's about the vertical, we know that the force y, instead of working with sine, we're going to work with cosine. So this one right here is going to be 80 newtons cosine of 50 degrees. If that's the case, for the fx, which is actually this side, we're going to work with this sine. So 80 newtons sine of 50 degrees. Force y is going to deliver 51.423 newtons. Force in x is going to deliver 61.283 newtons. Having to know all the forces and all the distances, we can just replace in the equations for the moment of couples. Dx, and my dx 0.5 meters, times force y, and force y 51.423 newtons. We do the same for the moment of the couple 2. dy 0.3 meters times force x 61.283 newtons. We will get that moment of the couple 1. It's going to be equal to 18.38. That's going to be newtons meters. And moment of the couple 2, it's going to be 51, oops, sorry, 25.7115. Oh, I got them mixed. It's going to be 2, it's going to be 1. Now, what are going to be the senses of these rotations? Remember to what we said. If we're working with vertical forces, if the force in the right it's going up and the force in the left is going down, we'll create a rotation that goes counterclock. That means positive moment. Now, if we work with a set of forces that are horizontal, and the force in the upper section goes to the right and the force in the lower section goes to the left, we're going to have a rotation that goes clockwise. That means negative. So we'll have a moment of the couple 2 of minus 18.38 and moment of the couple 1 plus 25.7115 positive. If we add them together to obtain the moment of the total couple, we're going to get 7.3315 newtons meters. That comes from the addition of this one too. This one negative, this one positive. Since the positive is actually bigger than the negative, we're going to have a rotation that goes like this. And that's going to be my answer for part A. For part B, we're asked to obtain the distance between these two lines. For that distance, we will use this total moment that we just obtained. So let's just copy this value. Copy the value. That's it. Now, use the result obtained to determine the perpendicular distance between the lines BE and DF. I already know that these two forces, this couple, will create a positive moment total of 7.3315 newtons meters. If I know that this moment of the couple can be calculated by perpendicular distance times force, and we already know the moment, we already know the force, we solve for the perpendicular distance. That perpendicular distance is going to come from moment of the couple divided by the force. That means 7.3315 newtons meters divided by the force. And the force, 80 newtons. With that in mind, newtons will go with the newtons, and we obtain only a result in meters. And that perpendicular distance, it's actually going to be 0.0916 meters, which is the same as having 91.6 millimeters. Now, that distance corresponds to this one right here, perpendicular to both lines. And we kind of can't see that was supposed to be actually a small distance. That makes sense with the result that we obtained here.